Okay, so for 8-5, compositions of rigid transformations, composition just means to combine, okay? We're combining two or more rigid transformations, which, if you recall, rigid transformation means that it does not change shape or size. So the ones we've learned about, reflections, rotations, and translations, we're just going to be focused on combining those, okay? Now, when we combine two or more rigid transformations that don't change shape or size, it doesn't change shape or size. So it's still rigid, okay? Also, the textbook likes to use a fancy term for a translation plus a reflection. They call it a glide reflection. Literally, that's just another way of saying translation and reflection, okay? These are two handy facts to memorize, okay? If you memorize these, you will be able to answer a lot of questions a lot easier. The first one is a composition of reflections across two parallel lines is a translation. Okay, what I mean by that, and I'm going to show you on the textbook. I have J here, and I have two parallel lines. We know they're parallel because of the arrows. Now, when I reflect J across here, I'll get a backwards J, right? And then when I reflect it back across this line, I will once again have a forward J. And here is the example of that occurring. Okay? So, what this means, what my little sentence here says, when we combine two reflections across two parallel lines, it's the exact same as just translating it. So reflecting twice across parallel lines is the same as translating. So I could have just called this a translation. The second one is a composition of reflections across two intersecting lines. It's called a rotation. And I'm going to show you up here. I have these two intersecting lines, and I start off with triangle ABC. Now, when I reflect it across here, it becomes a reflection, and I reflect it again, it ends up being the exact same as me just rotating this shape from here to here. So the composition combining two reflections across intersecting lines. So remember, if the only options are either parallel or intersecting, it's a rotation, okay? So this is very important. Next up, we have composition of translations. This we technically already learned about in here. To combine translation rules in a composition, just add them together. Just add your A's together, add your B's together. We've already been doing this. So there's really nothing new here as well. So there's two things to memorize, nothing new here. And then the most important part, composition of two different transformations. Now, we are so used to reading from left to right saying, hey, I'm going to do a reflection and then a translation. That's not how this works. We have to do the one closest to the shape or point first. So what that means is we have triangle ABC here. The one that's closest to triangle ABC is the translation first, and then we do the reflection. It is so important that we do these from the one that's closest to it first, okay? So when you're going through on Math Excel or the textbook problems or the worksheet or whatever it may be, make sure you do the one furthest to the right first. We're going right to left, not left to right, okay? Ignore how we read. We're doing it based off what's closest to the shape, which is so important. Let me show you guys an example of that. Right here, this is wanting us to translate and then reflect. So we don't want to read it as reflect and then translate. Sometimes it can occur where it doesn't matter which one we do first, but it's always to be better than safe than sorry. So always do the one closest to the triangle first. So triangle text, we're going to move it 5 down. So we're going to move it 5 down, and then we're going to reflect it over the line x equals 0. Well, the line x equals 0 is just the y-axis, so we're going to take that and flip it over the y-axis. That is how that works. Another type of problem is this one where we're working in reverse. On these ones, let it focus, it shows A double prime, B double prime, C double prime. Okay. This is very important. it gives us A double prime, B double prime, C double prime. It does not give us our starting shape. It is so important to notice that because that means we have to work backwards. We're saying if we took our original triangle ABC, we moved it 5 to the right and then reflected it across the x-axis to get this new triangle, I want to work in reverse to get back to the original triangle. It's asking me, what is the original triangle? So I'm going to work in reverse. I'm now actually going to read left to right. I'm going to reflect it back across the x-axis, okay, which is what they did here, reflect it back across the x-axis. And then if I originally moved it 5 to the right, I need to move it back 5 to the left. I'm doing the opposite, okay? That is so important. I'm doing the opposite. Now, if I would have taken the shape and just done it, say, hey, this was triangle ABC, let's move it 5 to the right and reflect it across the x-axis. I would have ended up with a triangle over here, which is not what my original triangle was. It's not wanting you to repeat these steps. It's wanting you to work in reverse order, which is confusing because I just told you not to read from left to right. But this problem is reversed, so we have to reverse how we solve it, okay? I know it's a little bit confusing, but as long as you do the closest one to the shape first, if you're given that shape, that is very important, and then move out from there. These two things, memorize them, will save you, and we've already learned about compositions of translations. So this is what 8-5, composition of rigid transformations, is all about.